Thank you. Yeah, this is Richard Fulton, computer science assistant professor at Troy University, Alabama. And
Diane Fulton, and from Clayton State.
okay, our table of contents: introduction, related works, artificial intelligence framework, key sector applications, and we're going to talk about the past, present, and future, and the triggers, and then there will be a conclusion. So, artificial intelligence is an evolving science and an art, and the scientific community changes its focus now and then. Technological developments will expand problem solving. Innovative capabilities of AI, we'll discuss that. Development over time leads to improved AI. Time evolving framework or AI. Past and present adoptions. Future expectations of technology. We have a lot of that at times, I'm sure. A lot of you do too. Triggers such as cost, speed, accuracy, customization, inclusiveness, diversity, and then there's cross-discipline and collaborations. State of the art of AI is impacted by 6 triggers, 4 influencers, and time. So influencers of AI adoptions are dramatic shifts in our environment, like coronavirus, we just had that, or we're still having it. Climate change, which is a big issue in some areas. Competitiveness in the industry creates a lot. Resources committed to AI, and that's important to improve where they're at. Whoops. Changing customer needs and wants. Okay, distinct industrial sector AI applications. There's 3 of them we're going to discuss: agriculture, education, and healthcare. So the first, technology adoption model. And there's 3 things that leads to the technology acceptance. That's perceived ease of use, perceived usefulness. And if you don't have those 2, a lot of people won't do it. Attitude towards the use makes a difference also. Whoops. One more. Yeah, here we go. Diffusion of innovation theory. And the diffusion is a process by which an innovation is communicated through channels over time among the members of a social system. And innovation is an idea, a practice, an object that is perceived as new by an individual or other units of adoption. And time, again, has a lot to do with it. Time literally flies, and diffusion is a process that occurs over time. Channels of communication are mass media. Interpersonal communications are used to diffuse information about new technologies and trends. And you can see people communicating in a lot of different ways, just right there. Mass media, we have a lot of that, and the newer satellite stuff too now. So, whoops. Social systems, set of interrelated units engaged in joint problem solving to accomplish a common goal. So you get these ideas and you analyze them, you have a lot of different areas to put together. Here's the people that are part of that. Innovation, what is perceived to be new, not necessarily better by potential adopters. So you can see there's different areas that actually go ahead and complete projects that others won't. Innovation is the innovators are 2%. You can see the graph here, the first part, approximately 2%. The first to try the innovation. Early adopters, early adopters are 14%. And those who are comfortable with change and adopting new ideas. It'd be interesting to see how many of you adopt new ideas easily. I think we do different things differently, you know, each of us. Early majority, that's 34% right here. People who adopt new innovations before the average person. However, evidence is needed that the innovation works before they will try it. Late majority, right there, 34%. Those who are skeptical of change and will only adopt an innovation after it's been generally accepted and adopted by the majority of the population. And then lastly, there's laggards, and they're about 16%, very traditional, very conservative people. They are the last to make the changeovers to new technologies. This category is the hardest to appeal to. So we have the unified theory of acceptance and use of technology theory, UTAUT, constructs and models. So performance, whoops. Sometimes mine just jumps. I don't know why it's doing that. Performance expectancy, the degree to which an individual believes that using the system will help him or her to attain gains in job performance. And we can see that that's important for a lot of people right there. Effort expectancy, ease associated with the use of the system. Social influence, the degree to which an individual perceives that important other believes he or she should be the new system. Facilitating conditions, how much an individual believes that an organization and technical infrastructure exists to support use of the system. Attitude, an individual positive or negative feeling about performing the target behavior. That's a good example in life for all of us, I guess, too. The measure of the strength of one intention to perform a specific behavior. That's the behavioral intention. Related works. So digital transformation journey. This all leads over to this area, which is business factors, technology factors, and trustworthiness factors. Mounting challenges and drivers goes to strategy, programs, processes, projects, and technology, and then transformational outcomes is what's left. And in a way, I look at that as our life too, as we change through life. International technology adoption models. Perceived benefits of technology adoption. Construct, combine, tandem, TAM, construct. Yeah, that's ease, useful, and attitude. All three of those are combined there. AI maturity model, a dynamic phenomenon to transformation. So now we're going to go from early AI interest with risk of overhyping, which happens sometimes, all the way on over to level 5, which is AI is part of the business DNA by then. It's all in, it's easy to follow through it. Two new concepts added to FAI: diversity, inclusion, and collaboration cross-discipline. Okay, so here you can see the graph of this stuff. I'll read down below. Some sectors adopt quickly, others cautiously. Advanced AI adopts firms increase, or adopter for firms increase market shares and growth. Triggers such as cost, speed, accuracy, personalization, diversity, inclusion, collaboration, cross-disciplinary work. Technologies develop over time also. So then we have the environmental changes like climate change and pandemic. Changing the priorities in a budget. We go through that a lot. Customers expect more and fiercer competition. Some definitions of AI: artificial intelligence, a technique which enables machines to mimic human behavior. Machine learning is a subset of AI technique, which uses statistical methods to enable machines to improve with experience. Deep learning, subset of ML, which makes the computations of multi-layer neural networks feasible. Applications in the AI sector. So you can see here, past, automation, the bomb, computer broke the Nazi Enigma code in 1940. That was a long time ago. They had to be proud of themselves on that. Present is computers engage in learning, adapting, synthesizing, self-correction, and use of data for complex processing tasks, such as Alexa here. Don't be interesting seeing how many have that. Car sensors, fitness tracking apps, fitness, wonder how many have those, and online customer service. So future, AI is a disruptor technology, impacts our lives and transforms how organizations function. What decisions should be made by humans? Which one by computers? And which one for both? That's a big area to talk about right there. Okay, now applications in agriculture sector. When I was a kid born in Illinois, we had a farm. We had no electricity for the first few years when I was born anyway. Life has changed a lot. I was just talking to my cousin who farms, and they have AI doing a lot. Anyway, AI expert systems, decision support system, quality control processes, climate modeling, neural networks for solar radiation, present, robots, automation, price behavior of food, using machine learning and artificial neural networks to expand and intensify industrial and technology farming. Future, intelligent farms, interconnected machines, systems, optimized resources, genetic engineering, precision agriculture, using data and imaging technology.
So the next section is on the education sector, and we're looking at the present situation. Coronavirus in 2019 influenced a lot of changes. We have digital technologies, the cloud, analytics, immersive learning spaces, teleconferencing, and digital curriculum. So 80% of all the educational institutions have allocated 25% to digital now in when they check the budgets in 2021. We customize and personalize in education now, not one size fits all. For example, my students use flashcards and they decide which flashcards they're going to review. They can do self-quizzes and self-exercises, and then they review just the concepts that they missed, adapting to what the student knows and doesn't know. AI is automated using automated tutoring and assessment with like Cogni at Colorado State University is a good example. And the last thing is the Go game. That was a very complex Japanese game. The AlphaGo computer program, DeepMind from Google, beat the #1 world Go player Keijiya at the Future of Go Summit 2017. In applications and educator sector is future, the AI contributions. We have the roles of students. They're changing. There's more participation. The students get to choose which mode of learning they have. As I mentioned, self-assessment, setting up social networks or groups, increasing their connections. Teachers, they're more coaches and facilitators. They analyze data about students, time spent on assignments, quizzes, details on concepts. Which ones are they learning? Which ones are they missing? Parents for school children, particularly more access to what kids are learning, what projects, assignments are coming up. Virtual assistants needed to learn language and responses from ontologies and semantic web and help students. Remote learning can coexist with on-ground or combination to address a diverse student body. And we have our next sector, which is medical healthcare. The past, cognitive aids were used for diagnosis, treatment, coordination of care, surveillance of patients, prevention, health and wellness of patients. And for example, we can monitor the diabetes sugar for a patient. Aids such as surgical safety checklist, operating room checklist, interactive aids for crisis care, medical simulations, helping patients with chronic health issues and setting up telehealth with patients from the AMA are just some of examples. Medical informatics, electronic medical records using tablets connected to computer systems to record patient information. Keeping records safe and private is very important. HIPAA regulations, we have to learn how to get electronic signatures over the computers, and tech impacts the security and ethics of the information. And in the present medical health sector, the medical profession is relying on image recognition tools that because they're outperforming physicians with skin cancer, reading x-rays, MRIs, and scans, although they still need a physician to verify it. The research firm Frost & Sullivan estimates that AI has the potential to improve patient outcomes by 30 to 40% while reducing treatment costs by up to 50%. Wearable devices, digital medicine, and machine learning, where AI mines data to detect anomalies and learns to accurately predict and diagnose diseases even earlier. And then it's also used, surgery is using robotics for brain tumors, retina, knee replacement, spine, heart, and uterine fibroids. It's becoming commonplace. And then the future for the healthcare sector, deep learning applied to radiology, dermatology, ophthalmology, cardiology, pathology will certainly be continuing in the future and expanding. They will use sensor-based systems to replace human rating systems for diseases which are more qualitative and subjective. The future will use machine learning to handle unstructured data such as images data, genetic data, trained with healthcare data to assist physicians with treatment and diagnosis. We will rely more on informatics and records, information management, treatment guidance for doctors, increased use of robots for elderly care and high intensity care such as neonatal care. And finally, we will use nano robots to deliver drugs for diseases such as cancer. And now we're into our final section of going over the triggers in more detail. The triggers, there are 6 of them, as you see in the model. We have speed, accuracy, cost, customization, diversity, inclusivity, cross-discipline, and collaborative. All are impacting what's happened with the technology over past, present, and future. So we're going to look at some examples in the speed. So in speed, time-consuming tasks can be taken over with AI tech, such as record keeping, assignment grading, filling out forms, freeing them teachers for more active learning and to help students more. Workers report that AI tech helps them to become more efficient, more effective. 70% say that in a survey. They're also productive and understanding, helps them to understand patterns, making insights and decision-making faster, easier for data access and use and work-life balance, and increases accuracy, such as the insights in learning. Our co-author, Susan Kaplan, couldn't be with us today, but we did interview her, and as she was helping with the writing of the paper, to find out what was her experience, because they had a joint venture partnership between Modal Technology, her and her son, Nate Kaplan, who is the inventor of the Alex machine learning software. And they worked, collaborated with the Research Institute of McGill University Health Center. And they worked with scientists, Drs. Lazarus and Matrakis. And those two working together brought about a synergy that basically compressed the network, used less data, got a non-statistically, mathematically provable training solution in a single run. So that was a lot faster, and answered the researchers' hypotheses. They were able to lower costs, get 100% accuracy predicting cancer by ranking the biomarkers, and they enabled the hypothesis, at least they figured out now it was feasible to develop a point-of-care lab kit for early cancer detection. And presently they're working with investors to make that dream a reality. And triggers of cost and customization. There are 3 cost-saving AI tech tools: virtual assistants or chatbots, human assist, computers routes tough questions to human, and screen assist, computer chat. These all address issues that affect customer service, costs, and revenues, and basically saves millions of dollars. AI also raises productivity and efficiency in healthcare delivery, improving care outcomes, patient experiences, and access to medical services. Customization will expand reach and engagement of the customer through the customer profile. And education will continue to experience more personalization. For example, Thread is the first picture right there. That is a picture of Thread, a UK company in the retail business, and they use virtual stylists. And I saw how they did it. They asked questions of the user, the consumer: what kind of style do you like? Pick out clothes that you like, how much money you want to spend, and are you more casual? What's your style? And that you actually even send them a picture of yourself so they can see what you look like. And so they make it very personalized. There's a human person behind it, but there's also, it says, an algorithm. So they work together to then give you suggestions about which outfits to buy. Hilton has a personalized concierge, a robot that's customized and will work with you for anything that you need. Maybe it's theater tickets or a reservation at a restaurant. So, and then that's the name of the game, is personalization and customization. Triggers of diversity and inclusion. Diversity, one of the biggest things that we saw with AI is that they've been criticized because there is some gender bias with some of the smartphone apps, Siri, Alexa, Cortana, Google Assistant, which is 92% of all smartphone apps have been using female names, voices, appearances. And that was because of the bias of the developers who believed female voices were more pleasing, helpful, and accommodating. There was also racial and cultural bias. Some of the wrong people went to jail, or AI failed to diagnose skin cancer accurately for people of color. AI apps that can't recognize words, accents, names, and interact with customers from around the world. And AI recruitment software was also considered racist. And then the whole idea of lacking trustworthiness. Bergen says that AI was fragile, opaque, biased, and not robust enough. Leaders must clarify values, evaluate biases, align organizational values with their products and services in AI. And inclusivity, it's important to hire more females and minorities for AI-related and tech jobs. Right now, about 25% are female and even fewer minorities in jobs. We also need to support and train minorities and females in the STEM areas with more advanced skills. And lastly, we need to create responsible AI that's fair, ethical, transparent, accountable, safe, and secure. And our final trigger is collaboration and cross-discipline. Basically, we're calling for partnering with ed tech and individuals and organizations to really make this happen. There's also challenges with human-robot interfacing. It's found that cross-discipline is very important because researchers who did those kinds of researches had better quality research, used more references, and created synergies to be more innovative. So more sharing of data, getting people from different backgrounds, cross-functional teams, and working to increase AI knowledge in all the disciplines, across disciplines. So in conclusion, we presented a framework for artificial intelligence that has influencers to adoption, triggers for adoption over time that influence the state of the art for AI. We stand at a unique precipice. There are new technologies to embrace, but competing in this next decade will require something more than tech and innovation skills. It will require a truly competitive vision, both for what these future works will look like and for what your enterprise or organization will need to become to succeed in them. Technology points us in the right direction, but the rest is up to you, me, and all of us. As from Accenture for their technology trends, their tech vision in 2022. Thank you. We'll take any questions you might have.